people in their 60s right now that really do everything they can to extend their lifespan and health span are going to find out that they can live to be 150. We're so close, and it's not just me, but other scientists too. There's a lot of things that cause aging. I'm working on one of them, which I think is the most significant. I think I'm working on the thing that has to be done, otherwise none of the other things will work. But still, when I succeed at what I'm doing, other things are going to have to be solved in terms of aging, and I think we're just going to keep living longer and longer. And I think 60-year-olds, 70-year-olds right now are going to be able to live to be 150.
What is it that you're working on?
I'm working on a clock that actually has been discovered. The people that discovered it won the Nobel Prize in Medicine in 2009. It's a clock that actually ticks inside of humans and also ticks inside of dog, cats, horses, pigs, deer, and sheep. But it doesn't tick in a lot of other animals like mice. It doesn't tick in mice, but it does tick in us, and it controls our aging process. When you count the number of ticks on that clock, we are limited to a maximum theoretical lifespan of 125 years. Now that clock is found at the very tips of our chromosomes. And if you think of a chromosome like a shoelace, the caps on your shoelaces are equivalent to the telomeres on your chromosomes, and the telomeres are where the clock is. It's been known since the 1970s that the tips of your chromosomes, the telomeres, actually get shorter as you age. But everybody believed that this was a result of aging, not the cause of aging. It was after we discovered that telomeres don't shorten in our reproductive cells, like the cells that are passed on from generation to generation. They just never get shorter. That we started looking, why don't they get shorter? And we discovered this enzyme called telomerase that keeps them from shortening. And when we put that into human skin cells, for instance, we found that those cells stopped aging. And now we've actually been able to do that with at least colleagues of ours at Harvard